Everyone, the next section is section 3.2, the chain rule and general power rule. The general power rule is actually a specific case of the chain rule. You need the formal chain rule if we had what we call transcendental functions like trig functions, sine, cosine, those sorts of things. But since we don't do any of that in BCal, it's not necessary. We can focus on just the general power rule. This will be how you work all your derivatives in this section. So a lot of people still call it the chain rule, but for us, we can just think of it as general power rule. So on my page here, I've just actually listed just the general power rule as the title of the section. So what it is this. We know how to do the regular power rule from chapter 2. We've learned the product and quotient rules in section 3.1. This rule is going to deal with having your variable buried in something that's in turn raised to an exponent. So for example, maybe you have something of the form y equal f of x. When I say f of x, that just means something with x in it that's in turn raised to an exponent. Our book generally uses r to represent an exponent. So it's something with x in it raised to an exponent. And it's actually a pretty simple derivative. Again, you don't have to simplify these. What you're going to do to get the derivative is take your exponent, slip it out front, so r just goes out front. You're going to rewrite f of x, in other words, rewrite what was in parentheses. So we rewrite f of x. Then we subtract 1 from the exponent. And then don't forget the last part here, times the derivative of what was in parentheses. In other words, the derivative of f of x, so f prime of x. Now with the product rule and quotient rule, we had a nice mnemonic for those. Unfortunately, I don't know of any mnemonics for the general power rule. We just kind of have to remember the format. But again, it's pretty simple. Exponent out front, rewrite the parentheses, subtract 1 from the exponent, times the derivative of what was in parentheses. That's all there is to it. Again, don't worry about simplification. So that's the formula, if you will, for a general power rule problem. Okay, so let's go to Hawks. See what you're going to see. We'll go and practice here. Okay, so a function like this, 1 minus 8x raised to 4. So again, the idea here is you've got something with x in it in parentheses. It's not just x, something with x in it, 1 minus 8x. X is buried in that parentheses. And then in turn, that parentheses is raised to an exponent 4. So we have 1 minus 8x all raised to the 4th. Let's go back over here to our other screen. There's our function. So 1 minus 8x is like what f of x was here. It's what's in parentheses. 4 is our exponent, so that's like r was here. Okay, so all we're going to do is just follow that format. We want our derivative, f prime of x. So we take that 4, we stick it out front. Okay. Then the next thing is rewrite what was in parentheses, rewrite f of x. So we had 1 minus 8x in parentheses here. Then we do r minus 1. So that's take whatever the exponent was and take away 1. Okay, so we had 4. 4 minus 1 will be 3. And don't forget the last part. This is a common mistake. That last part there, times the derivative of what was in parentheses. So in other words, what's the derivative of 1 minus 8x? Well, the derivative of 1 would be 0. The derivative of negative 8x would be negative 8. And again, you do not have to simplify anything in this course, so we can leave it like that. Again, exponent went out front. We rewrote what was in parentheses. We subtracted 1 from the exponent, and we multiplied times the derivative of what was in parentheses. Okay, let's go plug that in on Hawks. So 4 times 1 minus 8x raised to 3 times negative 8. Again, don't simplify. Don't worry about it. Submit. There it is. Okay. So pretty easy to do once you see it. I know when you read the section, things can be confusing, but once you see it worked out like this, it's pretty basic. Again, that 4 went out front. You rewrote the parentheses, 1 minus 8x. You subtracted 4 minus 1, so that was 3. And then you multiply times the derivative of what was in the parentheses. So you got negative 8 there. That's all there was to it. Okay, same idea here. Let's see if we can go ahead and write this one without flipping back over to the other screen. So I have an exponent of 3. 3 is going out front. I'm going to rewrite what was in parentheses. So that's 2x cubed plus 5. Then I'm going to subtract 1 from the exponent. So 3 minus 1 will be 2. And then don't forget, times the derivative of what was in parentheses. So the derivative of 2x cubed would be 6x squared. And the derivative of 5 would be 0. So that's gone. So again, exponent out front. Rewrite what's in parentheses. Subtract 1 from the exponent. Times the derivative of what was in parentheses. There it is. Pretty simple. Okay, same thing here. You got a negative exponent, but that doesn't change anything. I'm looking for one where we have, something like this, where we have a radical. Okay, so I've got the 4th root of 7x cubed plus 1. Okay, so let me take that over to my other screen here. So first thing, in calculus, whether it's Cal 1 or Cal 2, we do not like radical signs. So the first thing you should always do on any problem where you have a radical sign is rewrite it using exponents. So instead of saying the 4th root, we can raise to 1/4. That's the same thing. Well, now it looks just like the other problem. It's just you have a fractional exponent. Okay, but that really doesn't change anything either. Okay, so if we're going to do our derivative here, move that exponent out front. So 1/4 goes out front. Rewrite what's in the parentheses, 7x cubed plus 1. Alright, subtract 1 from the exponent. So what's 1/4 minus 1? Okay. Be careful. We see people make mistakes on that. 1's the same as 4 over 4. You got a common denominator now. It's going to be negative 3/4. And then times the derivative of what was in parentheses. So the derivative of 7x cubed would be 21x squared. The derivative of 1 will be 0. Again, don't simplify. So let's go ahead and put that in here. 1/4 times 7x cubed plus 1 raised to negative 3/4 times 21x squared. Alright, there it is. So again, if you see that radical sign like this one has, rewrite it using an exponent. So again, this is a 4th root, so it's the same as raising to 1/4. Okay, a problem like this, it's also got a radical sign in it. That's not really the main thing I want to show here, but we can still talk about it. It's a square root, so that's going to be the same as raising to 1/2. The other issue with this is your variable, which is t in this case, is actually in the denominator. So when we learned the power rule, we learned that the variable had to be on top. It's the same thing here. We need to rewrite this with the variable on top. Okay, so what we're going to do is do it in 2 steps. Let's flip over to my other screen. Okay, so we said we have the square root of t cubed minus 8 on the bottom. That's the same thing as raising to 1/2. So we have t cubed minus 8 to the 1/2 on bottom. Okay. So that got rid of the radical sign, but we still have our variable on bottom. So we want to fix that. We can shove this whole denominator up to the top as long as we change the sign on the exponent. Okay, so t cubed minus 8 is going to go up to the top. Instead of being raised to 1/2, we change the sign on the exponent. So let's raise to negative 1/2. And this looks similar to the other problems we did now. The difference is you do have a coefficient sitting out in front of the parentheses on this one. Didn't have that in the other two. For any derivative, if you have coefficients sitting out there like that, you can always just bring those down. So if I just go ahead and bring the 3 down, then really all I've got to look at is the rest of the function there, where I'd apply the general power rule. Okay, so 3 is just going to come down. That's all you're going to do with it. Okay, so let's apply the general power rule to t cubed minus 8 to the negative 1/2. So exponent out front, so there's the negative 1/2. Rewrite what's in parentheses, t cubed minus 8. Subtract 1 from the exponent. Again, make sure you subtract that correctly. 1 is the same as 2 over 2, so it's negative 3/2. And then we multiply times the derivative of what was in parentheses. So the derivative of t cubed minus 8 would be 3t squared. Don't simplify. Alright, so again, we had a radical sign. We changed it over to where we're using an exponent. Then we shoved that denominator up because our variable's got to be on top to do basically any derivative except for the quotient rule. Okay, after we did that, there was a coefficient sitting in front of the parentheses. Anytime you have a coefficient there, just always bring it down. So I brought the 3 down, and then the rest of the problem was governed by general power rule. Exponent out front, so there's a negative 1/2. Rewrite the parentheses, there's a t cubed minus 8. Subtract 1 from the exponent, there's a negative 3/2, times the derivative of what was in parentheses. So derivative of t cubed minus 8 was 3t squared. Again, don't simplify. 3 times negative 1/2 times t cubed minus 8 to the negative 3/2 3t squared. There it is. Okay. Now notice the difference here with this problem versus the one we just worked. You have 8x times x squared plus 5 to the 4th. That 4 is only on the x squared plus 5. X squared plus 5 is all that's raised to 4th. 8x is not a coefficient. In the last problem, let me flip back over here, you had a 3 sitting out in front of the parentheses. There was no variable there. Okay, so that was just a coefficient you brought down. It's different this time because you have a variable there. When it's a variable, you can't treat it as a coefficient. So what you've actually got to do is combine the general power rule, which we're learning now, with the product rule that we learned in section 3.1. Okay, so in other words, think back to that section. That was where you had first times second. Well, if you look at this problem, that's basically what you have here. You have something with x in it, 8x, that's first, times something else with x. Now this second part, x squared plus 5, has an exponent of 4 on it. You know, that we didn't run into that issue in 3.1, but we have it here. But again, what it's going to be ultimately is a combination of the two rules. And so let's see how to do this. Okay, so again, we'll call 8x first, and we'll call x squared plus 5 to the 4th second. We know the mnemonic for the product rule is first times the derivative of second plus the second times the derivative of first. All we're going to do is go in and fill into these parentheses. Again, we learned this rule in the last section. Okay, so first is 8x, no biggie there. D second, so we got to do the derivative of second here. Now notice again, you have that exponent on that parentheses. Okay, I want to write this out to the side. You may want to do this as well. It's a good way to keep things straight. Second is all of that, including that exponent. So if I'm doing the derivative of it, that's where the general power rule comes into play. So do this just like the last couple of problems. Exponent out front, rewrite the parentheses, subtract 1 from the exponent, times the derivative of what was in parentheses. The derivative of x squared would be 2x. So there's d second. All of that. 4 times x squared plus 5 cubed times 2x. Okay. Just leave it as it is. You don't have to simplify. And let's keep going. Plus second. Second is x squared plus 5 raised to 4. Don't forget that 4 there. And then d first. Well, that's easy. Derivative of 8x is just 8. Now, as ugly as that is, you do not need to simplify. So we did the product rule because it's x's times x's, first times second. So first d second plus second d first. Inside of the product rule, when we did d second here, I did it come to the side here, that's where the general power rule came into play. Exponent out front, rewrite what was in the parentheses, subtract 1 from the exponent, times the derivative of what was in parentheses. So let's go type all that in. It's as ugly as it is, that's okay. 8x times, let's see, I have 4 times x squared plus 5 cubed times 2x. All of that was d second there. Plus second, which was x squared plus 5 to the 4th. And then d first at the very end was 8. Okay, so 8x is first. That big set of parentheses there contains d second. Plus second is x squared plus 5 to the 4th. And then d first at the end is 8. So there we go. Again, you don't have to do any simplification. Okay, same idea here. You know, it's a little bit bigger function, if you will, but still doesn't change anything. You have x's times x's, and one of the parentheses has an exponent on it. So it works exactly like the problem we just did. So you would call 8x to the negative 2 minus 8x plus 9 as first, and 6x to the negative 2 plus 8x plus 9 to the raised to 3 as second. So all this is first, all this is second. Okay. Leave yourself some room here because this is again a bigger function. First, d second plus second, d first. Okay, and let's go through and fill in. So first is 8x to the negative 2 minus 8x plus 9. D second, so we need to kind of come to the side here. Second is all this stuff. And use the general power rule to get D second. So 3 goes out front, we rewrite the parentheses. Subtract 1 from the exponent, and I ran out of room there, but times the derivative of what's in parentheses. So negative 12x to the negative 3 plus 8. Oops. 3 times 6x to the negative 2 plus 8x plus 9 squared. I'm going to need a little bit more room. Times negative 12x to the negative 3 plus 8. Alright, plus second. Second is all that stuff raised to 3. 6x to the negative 2 plus 8x plus 9 raised to 3. And then d first. So the derivative of 8x to the negative 2 would be negative 16x to the negative 3. Derivative of negative 8x would be negative 8. Derivative of 9 will be 0. So there it is. Again, just do d second kind of on the side because that's where the general power rule comes into play. Let's type all this in. Plus 6x to the negative 2 plus 8x plus 9 third first. Okay, they really need to come up with a copy and paste function in here, don't they? But yeah, so it's really long, but the idea is simple. It's just first d second plus second d first. It's just that when you do d second here, you're doing the general power rule. There it is. And that's how you do the derivatives. So again, post on the discussion board if you need help. And I'll answer things there. Good luck.